Now that I've given you an overview of the structure and functionality of the ImageStreamGang app, we'll spend some time talking about how it's designed, and we'll talk about how to visualize the various interactions between the pieces that make up the parallel streams version of this app. This app enhances an earlier implementation called the ImageTaskGang, which you can also download at my website. And the ImageTaskGang implementation used various Java executor framework features, such as the executor completion service and the executor service, in order to be able to do pretty much the same thing we'll be talking about here. The new app, however, is much more interesting because it applies Java 8 features, functional programming features, and streams to do everything in parallel. Let's start by talking about what this app does. First and foremost, this is a much more interesting use of parallel stream than the version that we looked at for the earlier SearchStreamGang application. That application was a fairly compute-bound application. It was pretty simple, and it didn't demonstrate some of the more advanced features of Java parallel streams we'll be covering here. I should also point out that there's two different versions of the ImageStreamGang app, one of which is implemented using an Android GUI interface, and one of which is simply a command line interface. The actual source code we'll be talking about is completely portable between both versions, however, so we'll be focusing on that throughout the discussion. This app is also interesting because it demonstrates once again the power of combining object-oriented and functional programming features, where the functional programming features really are handling the computations, and the object-oriented features are helping to give the overall app a structure that lends itself to extension and flexibility. Here's what the app does. It starts with a list of URLs to images that are desired to be downloaded by the user. Those can be provided in various ways through a command line interface, through a file, hard-coded as some kind of test array, or given by the user using the Android GUI. And the first thing that the app does is it ignores any cached images. So if images have already been downloaded earlier, they'll be ignored. The next thing that we do is we go ahead and download the non-cached images. So if images have not been cached before, those images will be downloaded. And naturally, all of these images will be downloaded in parallel. The next thing we'll do is we'll go ahead and apply a list of filters to each image. These filters are probably better known as transforms or transformers. And they go and do things like do red eye removal, grayscale, embossing, sharpening, whatever kind of image processing you might want to do on the bits and bytes that make up the image. Finally, the filtered images are stored in the file system of the local device, which could be an Android device, which could be a laptop, could be something else that is stored in a more traditional way. After all that processing takes place, the images can then be displayed to the user. And there's a couple of different ways to do this. One way to do it is if you're running the GUI app, it'll actually pop open a new activity that works kind of like a cool variant of the Android gallery activity or gallery application. And of course, if you're running in a standalone non-GUI version, a command line version, then you may have to open up some other way of being able to view the images in a file browser of some kind. One of the cool things about this approach is it helps to closely align the stream pipeline, or more specifically, the parallel stream pipeline, with the description of what the app is trying to do. And so what this helps to do is helps to close the gap between the design intent, which is the description of the app, and the computations that implement the intent. And once again, it's really the functional programming features, especially the Java Streams framework, that makes this connection more direct. Let's take a look at how to visualize the various steps involved here with the different phases or stages of the pipeline. So we start with a list of image URLs that comes in as just an array list, and then we go ahead and convert that to a parallel stream. You can see here I've visualized the parallel stream. In this case, we have, say, 4 cores, so 4 threads, but in general it could be however many cores you have on your system is what the underlying fork join framework will use to organize the concurrency and parallelism at the fork join level. Naturally, that's all invisible to the application developer. Now we have a parallel stream that outputs a stream of image URLs. We then connect that as the input to the next phase or next stage in the pipeline. And what that will do is that will use the filter intermediate operation to ignore any cached images. You can see here that we use this method called URL cached, or more specifically a method reference to URL cached method, and we negate the result of that. URL cached, as we'll see in the next part of this lesson, returns true if the image is already cached, and we want to ignore cached images, so we negate the output of URL cached. So that's just a couple of method references being composed together. That will then output a stream of non-cached image URLs. So there may be fewer coming out of that filter phase in the pipeline as the result of, depending on whether things have been downloaded before. That stream of non-cached image URLs is then passed on to the next stage in the pipeline, which in this case is the map intermediate operation. And the map intermediate operation is going to use the blocking download behavior to download these non-cached images in parallel. So they'll all be pulled down by the different threads running in the fork join pool, and they'll be pulled down and processed. What happens there is we end up with a stream of downloaded images. So they're converted into image objects, which are meant to be, again, platform independent. That represents the bytes of the content in the images. And that then gets passed into the next phase of the pipeline, which is something called flat map. So the output of map is passed into the input of flat map. And what flat map does is it applies the apply filters behavior to each image in parallel and stores the filtered or transformed images in the file system of the underlying computing device. So what's kind of interesting to note here is we have a stream of downloaded images that comes out of map, and that is passed into flat map, and then flat map will actually generate a larger number of output images. And that's because it will apply each of the filter transforms to the downloaded image. And let's say that there were n images and m transforms, or m filters. We would end up with flat map then returning n times m images that have been filtered and stored. So that'll be an increase in the number of images in the stream that come out of flat map. That then turns into an input stream of filtered and stored images that are passed to the next stage in the pipeline, which at long last is a terminal operation. And that terminal operation is collect. And what that does, of course, is it triggers the intermediate operation processing for filter and map and flat map and so on for each image in the source. And then it goes ahead and collects all those things together and returns a list of filtered and stored images, which will then later be displayed through some other means, as we talked about earlier. The cool thing about this is that the Java 8 Streams framework orchestrates all of these steps in parallel. You don't have to know, you don't have to care what the threads are doing. That's handled for you by the fork join framework, which Parallel Streams handles for you underneath the hood as part of the Streams framework implementation. And all you have to do is concentrate on the behaviors that transform the list of URLs into the downloaded, filtered, and stored images, which will finally be displayed after all the processing takes place. So that's an overview of kind of the visualization of our program. And what we'll do next is we'll show how the Parallel Streams implementation of ImageStreamGang is actually realized in Java 8 code.